session of 62nd Joint Technical Conference. I am sure everyone is now geared up for the technical session after appetizing delicious lunch. This technical session is focused on machines, fiber and fabric development. There are 4 papers to be presented during this session. We are honored to have with us an incredible lineup of distinguished speakers who have made meaningful contributions in the field of textiles. So without further ado, let's dive right into the very heart of the technical session of the conference. To chair this session, it is my pleasure to invite Mr. Anup Pandey. May I request Mr. Anup Pandey to take his seat on the dais, please. Thank you, sir. Mr. Anup Pandey is a mechanical engineer having experience of around 34 years in different roles and responsibilities in June Textiles. Presently working as Assistant Vice President Works at Birla Corporation Limited, heading the operations at Birla Jute Mill. He is member RAC, ICAR, NINFAT, External Resource BIS, for providing awareness training on standards. He is life member of Textile Association India, life member of the Institution of Engineers. We are enriched by presence and look forward to his insights and contributions during the session. May I now request Dr. Nidhi Sisodia, Senior Scientific Officer ITRA, to honor Mr. Anup Pandey with a bouquet. Join the chair of the dais. Mr. N.K. Nagarajan from Citra. Mr. Parth Sanyal from Izira. Mr. Hitesh Dariwala from Mantra. Mr. Vishnu Nandi from Izira. And Mr. Joyjit Mukherjee again from Izira. Anup Pandey to begin the proceedings.
Machine and fiber fabric development. In this session, all the speakers are very renowned and very well-known persons, experts in their field. So, I just want to request all the speakers to complete their presentation by 12 to 13 minutes because we have very less time given to us. So, first I request Mr. N.K. Nagarajan to present. Mr. Nagarajan is postgraduate in textile technology from Anna University, Chennai. After working in reputed textile mill for few years, he joined Citra in the year 2005. He has been mainly involved in the consultancy services to member mills during the last 19 years in the area of productivity, improvement, cost control, modernization, manpower planning, techno-economic viability, valuation, and machinery, yarn realization improvement, yarn quality audit, etc. He has undertaken consultancy assignments in more than 100 mills, including foreign assignments in Indonesia. He is currently working in the capacity of head in charge of the spinning divisions. He has been studied over 30 SIPRA publications and 11 technical papers published in various styles. Please, Nagaland, start.
Thank you very much, sir. Good afternoon. Raw material cost contributes about 50 to 70% of the yarn cost. Everybody knows that's one. Actually, the yarn properties are basically based on the raw material parameters. Now let us go about the introduction. One of the primary factors that influences both processing and property of the final product is interaction between the fibers. And inter-fiber cohesion is an important aspect actually to consider. It directly affects the yarn strength and tenacity and indirectly affects the productivity in ring spinning also. And research studies shows that inter-fiber cohesive forces influence the individual fiber mobility within the yarn structure and yarn mobility within the fabric. And this project actually aims at the investigation of interfiber cohesion of cotton and its influence on yarn tensile properties in both Indian and imported cotton. Here, our objective of the study is to analyze the interfiber cohesion of both Indian and imported cotton, and second objective is to establish the relationship between fiber cohesive force and yarn tensile properties. Materials and methods. Actually, 20 Indian cottons and 22 imported cotton varieties were collected from the various mills, and fiber properties were evaluated using HK and Office Pro 2. And opening work and sliver preparation was done using MBTA 4. And cohesive force were measured using synchronous tensile tester, and the collected cotton varieties processed in the MBTA instrument to form sliver, and the same sliver was checked for the cohesive force using the swing tester. This is the MBTA instrument. Here you can see here fiber is formed in the feed belt, then feed roller will be there and opening roller will be there, and the rotor ring is there. From the rotor ring we are collecting the sliver. And method of sample preparation, actually method 1, the 5 gram of cotton was processed in MBTA for sliver formation, and sliver was processed in drop frame, single passage, number of doubling 4 and draft 6, and drop frame sliver was processed in open and spinning machine for yarn formation, count NE15, and yarn was tested for oil. And method 2, the same 5 gram of cotton was processed in MBTA for sliver formation, and again sliver is processed in drop frame, single passage, number of doubling 4 and draft is 6, and this drop frame sliver was processed in mini ring spinning machine for yarn formation, count 20, and yarn was tested for oil. Now let us come to the results and discussions. This is the Indian cotton quality, that is 20 Indian cottons what we have collected. Here you can see the MEC cotton, the cohesive force measure was different between 14.99 to 17.13 milligram force per text, and in case of Burnie it varies from 16.06 to 18.75, and in case of DCH 32 16.92 to 20.2, and in case of MC5 17.04 to 17.9. So we measured the cohesive force, and also we calculated the slenderness ratio. What is the slenderness ratio? Slenderness ratio is the ratio between the fiber length to the fiber diameter. That ratio also we collected, calculated, and this is the imported cotton quality results. Here also in Egyptian cotton, you can see here the cohesive force varies from 15.38 to around 27.29.68, and in Israel also 20.24 to 27.89. Like this, all the varieties we have checked with the cohesive force, and we selected the imported cotton variety, that is Israel Akashi and Peru Pima. Both are having the same slenderness ratio, almost same slenderness ratio. You can see here 3325 and 3370. So both are having the same slenderness ratio, but they are having the different cohesive forces. You can see here Israel Akashi is possessing the Gaussian force of 21.53 milligram force per text, and Perupima is having the Gaussian force of 17.37 milligram force per text. And then we process these Israel locality and Perupima fiber. We have processed in MBTA and we made the fiber, and we processed in OE as well as ring spinning. Then the results are shown here. You can see here in MBTA the total opening work is higher in the Israel locality. The cotton which is having the higher Gaussian force possesses the higher opening work and higher maximum power than the Perupima. And also in method 1, the tenacity, that is RK value grams per text, you can see here Israel locality possesses 19% higher strength than Perupima, and in the same time the ring spinning process also Israel locality possesses 10% higher strength than Perupima. And we selected the Indian cotton variety also. Here 3 Indian cotton varieties of different rings, that is MEC from Telangana and Maharashtra, and Bunny cotton from Bijapur and Karnataka, and DCH from Romania and MP. We collected. Here also we have selected the slenderness ratio, same slenderness ratio of both MEC, two cottons. You can see here the Gaussian force difference is 14.98 in Telangana cotton, and Maharashtra cotton is 17.13. And in Bunny Bijapur, you can see the Gaussian force value is 16.06, and Karnataka is 18.75. And DCH 32, you can see here that Gaussian force 16.92 for Romania, and Madhya Pradesh DCH is 20.2. And in the Indian cotton, we processed in the ring spinning method, that is, the cotton was processed in MBTA for sliver formation. Again, it processed through drop frame, and the drop frame was processed in mini ring spinning, and count 20, and ground was tested for RPM. Here also the results shown in this. Here also the same trend you can see for the cotton having the higher Gaussian forces possesses the higher tenacity. In MEC case the 12.7, that is 12.25 to 12.7 RPM difference is there. That is 4% increase in Maharashtra and cotton, and Bunny in case it is around 19% increase, 9.46 to 11.31, and in DCH 32 it is 15% increase, 14.9 to 17.1 increase in mercury was observed. This is a summary of the findings. Among the selected imported cotton varieties, the varieties that show higher Gaussian force, that is Israel locality variety, exhibited 19% higher yarn tenacity when processed in open end spinning, and 10% higher yarn tenacity when processed in ring spinning compared to Perupima variety. In selected Indian cotton varieties, those with higher Gaussian forces show 4 to 19% higher tenacity between varieties when processed in ring spinning system. Thank you very much.
Now I would like to request Mr. Partho Samyar. Mr. Partho Samyar, working as a scientist in Ijira. He is having 21 years of work experience, including 9 years of experience in quality assurance and product development in leading textile industries, and 12 years of research experience as scientist at Ijira. He is MTech in textile engineering from IIT Delhi and BTech in fiber technology from University of Calcutta. His area of specialization in mechanical processing of jute and allied fiber, jute-based diversified products like agro-textile, nonwovens, preforms for composites, packaging, etc. He has published 6 research papers in reputed textile journals and applied for 3 patents. He is life member of Textile Association and member of BIS subcommittee THD 03 and THD 14. Mr. Partho Samyar.
Good evening to system for jute drying. Although it's a roller drafting system, which is not a very new one in cotton system, but for jute, actually we are using the wheel drying system, and for introducing roller drafting in the jute spinning system is a challenging one. So that Now, jute is a very coarse fiber, it's a long, vast fibers, and it goes through a processing like spreader. It starts with a spreader where we apply the emulsion, and then it goes to the carding process, 2 or 3 passages of carding, where actually the filamentation occurs. Mainly from the jute reed to the finer filaments, it occurs through the transverse breakage and the longitudinal splitting. And after that, carding is the heart of the jute spinning process, and then after that, the sliver goes to the 3 or 4 passages of the twine, and finally it goes to the spinning. Now, during the drawing passages, actually, we align the fiber along the sliver, along the axis of the sliver, so that and along with the attenuation and with the doubling, so that the regularity of the sliver maintains in the spinning. Now, this is basically the Gilbert drawing frame. I request for the animations actually. This is how the actually gauge drawing system is happening here. Here we have Gilberts with the pins that penetrates into the slivers and carries the short fibers actually along with the long fibers to the next zone, that is the drawing zone. From the retaining roller, that's the retaining roller at the back, and comes to the drawing zone. And we do the activation, we actually straighten the fibers with the help of the Gilbert system. That's the basic principle of the Gilbert system. So during attenuation, drivers tend to become more irregular because in carding actually it goes to the 2 or 3 passages of carding. So it goes to a number of during the carding, a lot of short fiber generations occur. So that during the attenuation in the bronze fibers, it tends to become more irregular, but the wheel pins actually guides the system. Now to control the drafting irregularity, this Gilbert system is being used, and this is prevalent in the jute industry for decades, for centuries actually. And not much change is there in the jute spinning system till date. So there are some limitations in the Gilbert system because what we are running in the jute mill actually, the finisher card 2-gauge drawing system is running only with a speed of 50 meters per minute, where it is much low in comparison to the other spinning system. So why there is a limitation? I am talking about the finisher drawing systems now. That's the highest speed of drawing they are running actually in the jute mill. But the problem is that with this polar drops actually, with the Gilbert drops, the ability of the polar to withstand the forces involved in propulsion will be without excess amount of wear. The wear is a major problem. We cannot increase the speed up to a certain extent because of this falling of the Gilbert and then upstriking of the Gilberts to the sliver. To increase in the running speed of the 2-gauge drawing frame, actually with this drafting system will lead to the considerable machine breakdown and maintenance cost. Now we have found during the literature sets we have found that we should at work with the parallelization of the fibers in different processes of jute, where we have shown that from breaker cut, the food processing starts with the breaker cut. Breaker process starts with the breaker cut. So from breaker cut before and to the finishing, before the spinning process, the finisher drawing. So the parallelization of the fiber occurs between 65 to 95% of fibers. 95% parallelization occurs in the finisher drawing frame. But before finisher drawing, already 91% of the fibers being straightened. So the role of the finisher drawing frame is basically attenuate the fibers rather than straightening of the fibers in the drafting zone. that is, this polar bar waves actually causes a lot of problems in the finisher drawing system, and that goes directly into the spinning. There is no correction in it, and for that actually in the spinning, the irregularity, if we see that the major contribution, maximum contribution of finisher drawing goes into the spinning. It's around 40% of the total. The contribution is around 40% of that irregularity. So some development has occurred in the drafting zone. Somebody has worked with the Mr. P. Sahai has worked with the drafting zone with the roller drafting system of the drawing frames. So they have introduced the 3 roller drafting system instead of the skill bar system, so as to increase the speed. And what we have found in the finisher drawing stage, Dr. T.P. Khatwa has worked way back in 1978, and he had introduced some rollers instead of these skill bars, and he has checked the working of the roller drafting system in the drawing frame. So basically, the work of T.P. Khatwa, where it ends, we have started from that one. So our objective was to introduce the roller drafting system in the finisher drawing stage, was to increase the production from 50 meter per minute to at least double 100 meter per minute, and the standardization of the machine and process parameters for producing acceptable quality without deteriorating the quality as per the present norms, and subsequently to develop a prototype and the commercial model. Next. So we, as a proof of concept, we started with the tabletop model. Next, where we have introduced a series of rollers instead of the grid bars. Next. So this is the tabletop model what we have produced, and we have changed the quality of the slivers along with the steel drum frame parallel and tabletop model to find the efficacy of this roller drafting system in the zone. Next. And we have run it in a different, in the existing screw drawing frame in the jewel industry runs at a speed of 160 feet per minute. So we started with the roller drafting system with 3 different actual delivery speeds of 240 to 70, 300 feet per minute. 300 feet per minute is around 100 meter per minute. So we have checked the yarn quality parameters, count, strength, strength. So what we have found is that with this the tabletop model has worked well. It improves the efficacy of the system in the finisher drawing stage. So we have checked the Worcester percentage, CV percentage. So imperfections is also low in comparison to the student drawing system. So we thought that it will work in the system in the finisher drawing stage. Next. So these are the imperfections also, that is also low in comparison to the blue graphs. Actually, with the screw 160 feet per minute, even with the roller drafting of 300 feet per minute, we don't have any serious consequences of quality. When quality is at par with the screw drawing system. But with 240 and 270, it has gone well. Next. So with this actual concept, we started producing a pilot scale roller drafting frame. This is the pilot. This is the pilot scale roller drafting frame we have done, which has gone to the trial and the field trial also. Next. So this is basically, we have modified the earlier tabletop model to a production friendly, mill friendly, so that it can run smoothly in the mill. So we have done this. This is the drafting zone has been modified with the cemented rollers at the bottom with the positive drives, and with the maintaining and drawing rollers. Next. These are the kind of the Covey diagrams. So again, we have designed it again. That's the main drafting zone actually. We have introduced instead of the grid bar drawing system. Next.
2 more minutes.
So this is the material method. We have taken the standard second of wire, second white spool sliver, and the same spool sliver, second white sliver has been fed to the roller drafting system as well as the spool drafting system. And again, we have taken out the sliver, third finished white sliver to the same spinning frame. So, slip-cut spinning frame, 4/4 slip-cut spinning frame. So these are the pipeline distributions. What we have found is that with the screw wheel drawing system and the roller drafting system, there is improvement in the bead fiber length. Maybe because of the sleeve draft arrangement in the rollers, or there is no fiber breakage. Actually, fiber breaking has been minimized, I think. Next. And comparison to the screw wheel finisher drawing, roller drafting finisher drawing is almost at par. Slider bed variations is not much. Next. And we have made yarn out of it and compared the structure of the yarn parameters have been done. The strain series is quite satisfactory. This is important for the utility.
He is PhD in polymer matrix composites, MTech and BE from SB NIT Surat. He has more than 25 years in academic, research and industrial experience. He has illustrated over 7 publications in international journals. He is author of book Trend in Application in Polymer and Polymer Composite AIP publication, Melville, New York. He is life member of Indian Society for Technical Education, New Delhi, and corporate member, MIE, of the Institution of Engineers, India.
Thank you, sir. I am best. So the today's title of this presentation is the development of highly electro-conductive non-metallic textile for sensing applications and EMI switching. So as we know that electroconductive textiles are the group of the new materials that have significant potential in the areas of electromagnetic shielding, then electrostatic dissipation, camouflage, gas sensing particles, filtration, dust and germ free coating, and data transferring clothing. So the use of these base seals are popular in the areas of EM barriers to seal the devices, protective clothes for the persons in radiotherapy rooms or military applications. So basically these cans are prepared by using the metallic fibers such as the stainless steel fibers or the metal coated fibers, but the use of these metallic component in the textile, they however destroy the intrinsic flexibilities of these materials. So this problem can be overcome by using the inherent conductive polymers such as polypyrrole, polyethylene and their derivatives. So the polypyrrole is established as one of the most promising electroconductive polymers. The next please. Okay, so this project focuses on creating the flexible electroconductive textile using polypyrrole in situ chemical and electrochemical polymerization. So it aims to optimize the process parameters of this particular project. And the overall objective of these projects are listed here to develop the high electroconductive fabrics by in situ chemical and electrochemical polymerization, and to characterize the developed electroconductive textile, to test the feasibility of the developed electroconductive textile as a different sensors like gas sensors, mechanical sensors and electrical sensors, but to test the EMI shielding properties of these fabrics and to find the relation between the conductivity and the EMI shielding efficiency, and to find the optimized parameter for the maximized EMI shielding efficiency. So these are the materials and methods. So main is the base fabrics, then chemicals and electrodes. Next please. So here fabric chosen, polyester was chosen as electroconductive fabrics. The properties of the chosen polyester fabrics are listed in this table. Then different chemicals are chosen, like pyrrole was used as a monomer and ferric chloride was as an oxidant. P-toluene sulfonic acid used as a supporting electrolyte. Graphene have been used as an enhancing material, and all these are the laboratory grades. Electrodes are used of the SS materials. These are the flow of the total metrology, where the preparation of the electroconductive fabrics using chemical polymerization and electrochemical polymerization, and the characterization of the electroconductive fabrics. See, the preparation of the electroconductive fabrics was done by the first method, chemical polymerization, which is listed here. So generally monomer has been dissolved in the water, and in the first step the hydrolyzed fabric was immersed in the pyrrole solution, which containing the 0.5 mole pyrrole at 25 degrees Celsius for 20 minutes, and then the pyrrole ended fabric was immersed in the 0.75 mole farad chloride solution, so as to initiate the polymerization onto the fabric at the 5 degrees Celsius for the 10 minutes, and the polymerization temperature was further reduced to facilitate the better yield, considering that the chemical polymerization is exothermic. And afterward, the fabric was washed through with the deionized water, and then it is dried in the oven. So this is the process we conducted as electrochemical polymerization, where the power supply is given to the electrolyte monomer when the one fabric is fixed at the anode and one is working as a cathode, and the DC power supply was supplied, and that process has happened. And after the power supply is activated, the polymerization begins, and the polymer becomes deposited onto the surface of the textile material covering the anode. So these are the characterization of the electroconductive fabrics, where anodes are there. So weight of the polypyrrole added to the fabrics, then SAM is done, then FTIR and the TGA. Okay, next please. So the surface resistivity was measured. So it is the film that was determined according to the ASTM D257, and this is the equation that was used to find out the surface resistivity, where RS is the resistance of the sample, while OS is the surface resistivity. Similarly, the electromagnetic shielding has been determined using the formula which is mentioned on the screen, where eta denotes the shielding effectiveness and P1 denotes the electromagnetic power which is received by the antenna in absence of the electroconductive fabrics, and P2 indicates that power received by the antenna in the presence of the electroconductive fabrics. To carry out the entire experiments, the response surface methodology has been chosen, and for that 3:3 box Manhattan design has been selected, and the equation, quadratic equation has been mentioned here. So here the Y1 denotes the electrical resistivity, and X1, X2 and X3 are indicating the graphene concentration, system current and the polymerization time, where beta 0, beta 1 and beta 3 etc. are the constants. So this is the table we can see here. The levels of the input parameters has been chosen for the graphene concentration, system current and the polymerization time, and on the basis of that the design software has been used, and for that 3:3 box Manhattan design has been selected, where 5 central point has been selected, and there are total 17 runs of the experiments which are listed in this table. So now result and discussion. So finally, after running this software, this equation has been given by the design expert software, and where Y2 is the predicted resistivity of the fabric. So these are the results which are obtained for the different trials, where the comparisons of the resistivity experimentally obtained and the resistivity which are the predicted by the use of the formulas. This is the ANOVA table. Okay, go ahead. So these are some findings where the effect of the graphene concentration and the current of electrochemical polymerization of the fabrics, where the contour plots are drawn. So from that it is clear that the resistivity decrease with the increasing current, and the both graphene concentration attributed to higher polymer yield, but graphene concentration had a comparative lesser effect than the system current, with reduced resistivity mainly due to the enhanced polymer formation on higher currents. Okay, next is the effect of current and the time of the electrochemical polymerization. So here polymerization time increase, resistivity decrease at lower current, but it remains relatively stable at the higher current. So this decrease is likely due to the enhanced polymer formation and uniform deposition over the time. Next is the effect of graphene concentration and the time of electrochemical polymerization. So here the decrease, resistivity decrease as the polymerization increase at both low and high graphene concentration, but primarily due to the greater polymer formation as a more time was available, the graphene concentration had a lesser impact than the polymerization time. So with the reduction in the resistivity linked to more polymer formation to extent. Here are some images of the SAM. This is measuring the chemical polymerized fabrics and electrochemical chemical polymerized fabrics, which is indicating that the electrochemical polymerization with greater deposition of the polypyrrole result in lower surface resistivity, while chemical polymerization it shows the comparatively less deposition and higher resistivity. Some FTIR spectrum of polymer on surface resistivity of the fabrics done, and the difference bands are obtained, which are the findings of the conformation of the polypyrrole. Then the thermogravimetric analysis has been done of the polypyrrole film, where it is observed that even at the very high temperature at 598 degrees Celsius, only 42% weight loss occurred. The voltage current characteristics of the electroconductive fabrics is also analyzed, and the trend is observed, and this exponential manner has been observed in the results, where I is representing the current V velocity voltage and A the coefficients. Similarly, the voltage temperature characteristics of electroconductive fabrics is also observed, where the voltage temperature characteristics showing by applying various DC voltage at different time intervals, which we can see the results in the first figure 9 graphs at different time level. And secondly, the exponential relation of delta T represents the temperature increase. V is the application time, and C and D are the coefficient of the exponents. Some static charge on the electroconductive fabrics has also been studied, where the static charge, the total developed charge has been measured in volt and the half decay time expressed in the seconds. So results are listed in the table. So it has been found that the charge generation and the half decay time have been dropped significantly in the case of both the conductive samples. Some pressure sensing properties of electroconductive fabrics. So this pressure sensing property of electroconductive fabrics have been also shown in these tables and the graph. These are the gas sensing properties. And these are the results that the demonstration of highly electroconductive have been shown in the figure in open circuit and the closed circuit, where we are showing the glowing of the bulb. Finally,
Specialization in mechanical processing of jute and allied fiber, product and machine inspection, machine development, etc. He has applied for one patent on automized jute spinning system. Mr. Jagjeet Mukherjee is working as a technical officer in ISRA since 2002. He is diploma in mechanical engineering from Hooghly Institute of Technology. He has 24 years of work experience, including 7 years of experience in jute, glass and engineering industry, and 17 years of research experience as technical officer at ISRA. He renders his technical consultancy support to the jute mill on upgradation of maintenance practice, digitization of maintenance management system, productivity enhancement by rectification of process and machinery, training on skill development for jute workmen. He has applied for 3 patents.
Thank you, sir, for introducing. Introduction. ISRA has developed a technology for speed regulation in conventional jute spinning machine by retrofitting advanced electronics to adjust and regulate fly RPM, draft, twist, traverse speed, and bobbin dimension and auto-doping, etc. instantly with a human-machine interface. This technology eradicates mechanical limitations in existing conventional slip draft 100 to 120 spindle spinning frame in view of machine or yarn parameter change option, maintenance cost, running efficiency, workload of operator, bobbin length and shape, and energy. Next. see what are the limitations in conventional tube spinning machine. The existing spinning frame system is run by single induction motor with large number of gear threads and chain drives, etc. Frequent machine breakdown due to spare parts failure, worn out sprocket and pinion deteriorating quality, high maintenance cost, skilled mechanic required. Machine is kept idle during change of flare RPM, draft, twist and traverse speed. Exact draft or twist and speed may not be set due to non-availability of spares and mechanical element in the machine. Manual docking increases the operator workload. Costly mechanical modification is required for bobbin length and shape change. This is the photograph of conventional machine and retrofit automation. You may see that we have introduced one human machine interface on the right side of the slide. Whenever any change, we need any change like draft, speed or twist, we have to just give command to the human resource HMI and the machine will set this parameter accordingly. There is no mechanical intervention or manual intervention needed in this technology for speed regulation, draft change, twist change or traverse change or auto docking. Next, let's start the video. This is the video showing the present operational video of conventional tube spinning machine. You may see how primitive type of power transmission system still existing in conventional tube spinning machine. So to eradicate this age-old power transmission system through gearing on sprocket drive mechanism, we have made this spinning mechanism software control. In our system, there is no intervention of any gear, train, lever, etc. This is already done by the software control mechanism. I will see you a complete video in the later phase of our presentation where you can see that our technology is operating successfully in one reported tube mills in Kolkata. This is present to make a mechanical soft start of the machine. Bobbin building mechanism is controlled by complex hard wheel, hard cam, hard lever mentioned as E. Traverse rate is changed by changing traverse pinion D, and docking wheel F is used for manual docking operation. Next slide. Now this is the retrofit automated tube spinning frame. What kind of modification we have made in this system? The power source is distributed among various motors. We split up the single motor driving system into 4 motor driving system. We have driven the respective rollers separately by the motors, different motors. In this case, the main cylinder B is driven by a separate induction motor of 10 horsepower capacity. It is mentioned as A. The main cylinder filter shaft is driven by a separate servo motor of 2 kilowatt with a reducing gearbox as mentioned in C. In this system, you can see that irradiating ring size system. There is no need for ring size system here. The soft start is maintained by the programmable logic system. The irradiating 10 number of gears from this driving side. Irradiating age-old hard cam, hard lever type bobbin building arrangement, and servo system is controlling the bobbin building and traverse mechanism. Now this is the rear side of the conventional tube spinning frame. You can see a complex gear sprocket driving arrangement to drive the bottom roller and the top roller. The bottom roller drive is controlled by twist change speed and TCP A, and the top roller speed is controlled by draft change speed and TCP B. Next. This is the modification done here. In the individual power transmission arrangement at rear side, 2 separate motors are used for bottom and top roller. Bottom roller A is driven by induction motor of 5 HP capacity with a reducing gearbox B, and top roller C is driven by servo motor of 1 kilowatt with a reducing gear D. Here is a 11 number of gear including draft change pinion and twist change pinion and sprocket from the rear side. Next. This is the panel box. It is attached to this machine. Inside this panel box, there is the VFD, this variable frequency drive, the servo drive, etc. This is the inside of the panel box. VFD1A is controlling the speed of the main motor. This is driving motor of 15 kilowatt. The VFD2, as mentioned in B, this is controlling the drive of the bottom roller of 5 horsepower motor. Servo drive 1C is for 2 kilowatt servo motor. Servo drive 2, as mentioned in D, used for 1 kilowatt servo motor. And micro or motion controller is used for speed synchronization of this 4 number of motor as per command received from HMI. This is a schematic diagram of working principle. Actually, in this case, we know that any spinning parameters or spinning machine parameter is a ratio of different rollers, speed ratio of different rollers. So wherever we want to change the speed ratios in the draft or twist or speed, we actually change the speed parameter, speed ratios of this roller. In this case, the total driving arrangement, such as the main flyer RPM, the water roller RPM, feed roller RPM, and the traverse speed, every parts is controlled by a separate motor, and everything is controlled by a microcontroller. The speed of this speed is controlled by the microcontroller. Whenever a change is required or the command is given to the HMI sends the message to the microcontroller, and microcontroller sends the signal what speed is required to the drives, the servo drive 1, 2, and VFD drive 1 and 2. Accordingly, the drivers control the speed of the 4 motors. Okay, next slide. This is a spinning cycle. Actually, software program is controlling the total operation, that is stop start, bobbin building, stop stop, automated bobbin rail and downward movement to home position, manual rail shifting, automated bobbin rail, upward movement to ready position, inching and yarn cutting. All these operations, the time duration is controlled by the spinning cycle. Now the features of this retrofitting system. So what are the features? Let's see. The software controlled spinning mechanism, use of HMI for machine and yarn parameter setting, the auto doffing, gearless smart drive mechanism, machine soft start and stop stop, option for auto mode running and manual mode running, easy bobbin changing, energy efficient technology, doff recording and display, running efficiency recording and display, energy consumption recording and display. Next. Human machine interface features. So we have introduced HMI. This is the home page of this HMI. What are the options? The different buttons for parameter setting and data display, auto mode, option for manual mode, option for roller setting, option for machine parameter, option for quality parameter, option for energy consumption, and doff record. Every screen, every functionality is a password protected. Whenever we want to change or enter into a functionality, we have to put a selected password. So only the authorized person can open this windows. Now I would like to call Mr. Jajit Mukherjee to present the rest of this presentation. Okay, thank you.
Thank you.
Thank you, Mishwaru. Good afternoon to all of you. Now, I am going to present you the reciprocating motion of this machine. Mishwaru has shown the features of the machine and rotary motion of the machine. I am going to show the reciprocating. That is draft, twist, RPM, doffing time 1, doffing time 2, soft start, and cycle time. Okay, next. And this is the 7 parameters line here, over here, which I have shown you. Next. And it is the manual mode. Also manual mode is there. If somebody wants to take the machine in manual mode and switch and operates through switch button, then go to manual mode and next slide. And in case of manual mode, only 3 things have to fill up: the flyer RPM, draft, and TPI. Then save button. Next. There is the manual mode switch, manual start, manual stop, and inching. And in case of builder reciprocating motion, home, ready, and top. These switches are there, and of course emergency button is there if somebody wants to stop it emergency. Next. Now this is the builder setting motion, and this is more important, builder setting. I am going to show you the next slide. Next. Video. Now it is a conventional spinning machine. Here you can see the hard cam, hard lever, bobbin rail, chain, etc. And here mechanical adjustment is quite difficult. If we want to adjust the bobbin traverse length,
have to adjust the top portion, the top slide, you have to move it, and turn buckle is also there. If you want to put it up, then we have to twist the turn buckle. It is already a complex for conventional spinning machine. Next. It is a picture of conventional spinning machine. Where we can see these things. The hard cam, it is asymmetric. Hard cam, it is also symmetric. Hard lever, etc. Everything. It is a clumsy one. Next. And it is our retrofit machine driving with builder. It is a reciprocating builder motion. Look at this, it is just simple one, only one motor of 2 HP, 2 kilowatt. It is running the whole builder arrangement, and we can set the builder motion very easily by putting the data. Here 3 position is there. Next slide. Yes, here home position, mid, ready, mid and top. 4 position is there. Home, we set it at 0. Home 0 and home to ready. Ready, home to ready means just top of the bobbin touches the flyer. This is called home to ready, and 212 millimeter it is in case of our 4-quarter spinning machine. And ready to mid and mid to top. This, if we add these 2 distances, we can find the reach of the bobbin, that is for 6¼ inches. This is, and the corresponding time. Home to ready, it takes 8 seconds. Ready to mid, 30 seconds. Mid to top, 30 seconds. And downtime, it is stated over here. We can change it easily. The position and the time. Very easily we can change it at HMI and put the set button, then it will be activated very easily. And we can change speed, we can change the traverse rate very easily within a second. But in conventional machine it is not possible to change. Actually we have to change the whole system, cam, hard lever, etc. It's a long time, and also costing is there also. Next. It is an additional, we are putting here additionally we can see the total energy consumption. As we have used the servo motors, so we can easily have, and also we have the multimeter arrangement here. From multimeter we take the total energy consumed, and from servo motor we take the total running hours. By computing this, we can easily find the consumption of electricity, and also the dot count is there. Whenever the ray touches the bottom of the then it is counted as dot, and total number of dots we can easily found in the display. Next. This is the shift-wise timing. We can easily found from it the efficiency, shift-wise efficiency, how much efficiency the machine is running according to the shift, according to the brake shift. Next. And it is the full video of our machine. It is here left side, it is the HMI. The first page is totally software operated. In one click, the machine can run throughout the day, only one click in auto mode. This is the running of the machine, it is running in auto mode. This is a manual switch. Now it is running in auto mode. Top left side, that is the builder position indicated there. It is a main motor, that is the 10 HP motor, and here before that is the servo motor of 2 kilowatt. It is special type of servo motor. brake servo motor, that is. It can, it is a reciprocating one, just reciprocates the builder rail upwards and downwards. 3 terminals are there. It is a special type of servo motor. This gearbox is 1:40. Gearbox is headed. Gearhead motor it is drawing roller. This is a drawing roller. It is the induction motor, 1:10 gearbox, and it is the 1:20 gearbox, 1 kilowatt motor running the top roller. This is the auto stop. Machine stops according to our requirement. It can stop in 30 seconds or in 60 seconds, anything. And it is the auto doffing. No need to turn the hand to it. It is just drops automatically. According to the time, according to the cycle time given to it, the machine. And only to shift the rack shaft by weight. Docking time is there. 30 seconds or 40 seconds is there. After 30 seconds, the builder went up. Yes, it goes to the ready position. It is the ready position, ready, and then inching. This is the inching, yarn cutting. It is manually yarn cutting. Then machine starts automatically. It completes the cycle. This is the panel box. Cooling arrangement is also there. 2 fans for cooling. The machine is running for last 4 months in Ombika jute mill without any interruption. These are the 4 drives. This is induction, this left side to our induction motor drive, and this is servo drive. Yes. Is password protected?
The judges conclude we are already
Next. This is the result. We have tested 5 samples and we have got same at par as compared to conventional machine. Next. Same that we have also. This is the process line. We all know spreader, inter, piling, breaker, then finisher, then 3 sets of drawing, then spinning. Next. This is the count we have tested and got good result. Actually, at par result with conventional machine. Next. Okay, actually advantages. Doffing loss, one of the advantages. Machine efficiency. It can increase the machine efficiency and of course the power consumption. 1 kilowatt per hour. It is the savings. Next. Actually, in conclusion, it is actually the first machine in jute industry that automation, as far as spinning is concerned, and automation, we have started automation. First spinning, this is, and we hope that in near future this technology will
Thanks to the organizer and Mitra.
Ladies and gentlemen, we have come to the end of a very interesting and enlightening session. I am sure everyone present here have enjoyed the same and have gained vital inputs that would be very useful to them in their professional life. May I now request Mr. Anup Pandey to honor the speakers with a memento. Mr. Ritesh Jariwala. Mr. Vishnu Nandi. Mr. Joyji Mukherjee. To honor the chairman with a moment. I express my sincere thanks and gratitude to Mr. Anup Pandey for sparing his valuable time from his pressing schedule for the conference and conducting the session in a lively manner, incorporating his own textile expertise and personal touch. We have been enriched by your presence, sir, and hope you have also enjoyed the session as much as we have. I also thank all the speakers for having presented their papers in a very nice and lucid manner. I am also very thankful to our esteemed audience for our active participation, making this session a vibrant pool of knowledge exchange. It has been a pleasure hosting this wonderful session. It has been an overall intellectually enriching experience, and we trust you all depart with a better understanding and fresh perspective on conventional and technical textiles. Thank you.
Good afternoon, ladies and gentlemen, colleagues and my dear friends. It's my pleasure to invite Textile Commissioner Ms. Roop Rashi ma'am to chair the panel discussion. Ma'am, could you please come over the dais? In this session, I would like to invite Professor B.K. Kothari, Eminent Professor IIT Delhi. Sir, please take your seat. Now, I would like to invite our DG Sir, Dr. Arindam Basu Sir, to honor Ms. Roop Rashi ma'am with a bouquet. Kothari, Professor IIT Delhi. Thank you, sir. Discussion, I would like to have a small ceremony. We would like to have a small ceremony, and it's my privilege to stand before you today to honor someone who has dedicated 25 years of their professional life to our organization. This is a special occasion as we celebrate not just longevity but loyalty, hard work and dedication. So, before starting this function, this small ceremony of felicitation, I would like to invite our panelists to please join on the dais. Mr. Praveen Kumar Kora, GM Marketing, Arvind Limited. Sir, please. Setin Raina, MD, Director, Business Development, Arcroma, MD, Geosys India Infrastructure Limited, and Mr. J.K. Gupta, Director, Textiles, Bureau of Indian Standards, New Delhi. So I'll continue with that. So we'll start with the felicitation process. Over the years, our colleagues have demonstrated unwavering commitment, exceptional skills, and a passion for making our workplace better each day. Their contribution has shaped the success of our organization and have been a source of inspiration for all of us. Today, we gather not only to recognize them but also to express our gratitude for their countless achievements. NITRA has a rich tradition of honoring its employees who have completed 25 years of distinguished services at NITRA during JTC. Continuing the tradition, this year also, we have 25 employees who have completed 25 years of service. So I will request Ms. Roop Rashi ma'am to honor them today. On the stage, Mr. Umesh Pathak, Mr. Vivek Agarwal, Mr. M.K. Bansal, Mr. Mukesh Kumar Tomar, Mr. G.C. Vajpayee, Dr. B.K. Sharma, Mr. Sanjeev Shukla, Mrs. Seema Sharma, Mr. Harendra Singh, Mr. Kuldeep Singh, Mrs. Seema Sharma, Mr. Harendra Singh, Mr. Kuldeep Singh, Mr. Partha Basu, Mr. Abbas Raza, Mr. Ganesh Lal, Mr. Devendra Singh, Mr. Swami Saran, Mr. Devendra Singh, Mr. Swami Saran, A.A. Rizvi, Mr. Sanjay Gupta, Sharma, Mr. Satyanarayan V, Mr. Vikas Sharma, Mr. Satyanarayana V, and Mr. Narendra Singh. Congratulations and here's to many more years of success together. Now I hand over the session to Ms. Shweta Saxena.
Ladies and gentlemen, in the sideline of this 60-second Joint Technological Conference, we have also organized a poster presentation competition on various scientific themes like recycling, sustainability and protective textiles, and other related fields of technical textiles. We had a nomination of 21 posters that are displayed on board and our respected members of the jury, Dr. Dipali Palawar, Senior Deputy Director TIRA, and Mr. Naveen Gupta, Star Safety Hub, have evaluated these posters over these 2 days. Now it's time to award the top 3 positions. Now I request Dipali ma'am and Naveen sir to come on the dais to announce the winners of the poster presenting competition. Thank you. So third prize goes to Mr. Saurabh Banerjee from IIT Delhi. He displayed his research on base fruit part-dried polyphenolic extract. Second prize goes to Miss Rupali Kakaria. Is on development of grapefruit essential oil microencapsule for evaluation its mosquito repellent properties on cotton. Das from IIT Delhi. A big round of applause for him. Dipali ma'am and Naveen sir for your valuable time. Thank you ma'am. Thank you.
Thank you, Dr. Neha and Dr. Sweta for conducting the felicitation ceremony as well as the poster presentation. Ladies and gentlemen, now the 62nd Joint Technological Conference is almost coming to an end. During these 2 days, we have witnessed presentation of 26 technical papers from 8 TRAs and 24 brilliant scientists presenting the papers. We have had wonderful and innovative ideas emerging out of these presentations and Q&A sessions. However, it is not yet over. We have slated a very interesting panel discussion by industry experts to conclude this mega event. We are also very happy that Ruprashi ma'am, the respected Textile Commissioner, has also joined. The session will aim to understand the impact of technical textiles on domestic and international markets from an Indian manufacturer's point of view. Besides, the need for quality control for providing quality products to the users will also be discussed. Ladies and gentlemen, our panel moderator, Kothari sir, has completed his BTech from IIT Delhi. He followed it up with MSc Tech from UMIST, Manchester, and PhD from Leeds University. He has 41 years of rich experience in teaching and research activities at India's premier institute, IIT Delhi, in the Department of Textile Technology. He retired as Emeritus Professor. He has to his credit 198 publications in research journals, 96 papers in various national and international conferences, 83 publications in great journals. Besides this, he has contributed 12 chapters in books and has edited 6 books. Now, I am very pleased to request sorry for the little inconvenience. Now, I would like to request our respected panel moderator, Kothari sir, to take over and conduct the panel discussions. Sir, please.
Textile Commissioner, Rukrani Madam, extremely experienced panelist on the dais. I'm happy that the last session of the Joint Technical Conference has come and it is focusing in general on technical textiles. We would really go by first having the small take on the technical textiles by the panelists, and then we come to the specific questions which you might really have or we have to ask them. However, with the first panelist, I'd like to take the opportunity to ask the questions right in the beginning because he has to leave immediately after his presentation. So our first panelist this evening is Mr. Praveen Mora, who is the General Manager Marketing of the Human Protective Division of the Arvind Advanced Material Group. He has very rich experience of 20 years in marketing and is a techno-commercial person with technical degree in BTech and also the MBA in marketing. He is going to be throwing some light on what the protective textiles of the Arvind mills are doing. In particular, we like him to really look at what are the type of protective textiles which are exported from the Arvind textiles and what is the scope of protective apparels in India in general. So I'll request Mr. Mora to really throw some light on the technical textiles in general, protective textiles in particular, and his take on the export market as well as the Indian market for the technical textiles, especially the protective textiles. Thank you.
Before we get into the detail of what protective textiles we are doing at Arvind and how we are making it, where we are supplying, I think as a country we are a little late on this technical textiles manufacturing, but fortunately Arvind started this division called Arvind Advanced Materials Division in 2008. So where a dedicated team is separated and made to cater to the human protection needs. So we call this human protection division where I work as a general manager marketing. So in this division we try and save any human into different kind of work environment or any sort of hazard that can happen to a human life. When it comes to hazards, things come to our mind like there would be a fire or earthquake or molten splash or something. But if we go look at the culture in the foreign countries, protection has to happen in many ways. So at the moment we are supplying 70-75% of our produce to outside India, over 50 countries globally. So here in this year we are doing some 4 million units of garments that we will be supplying across India and globally. So at the moment 75% approximately goes in the export market. There we give solutions to save the human life from hazards. Like hazard can come in any form. Even if a worker working on a road repair or doing some gardening work, there has to have a uniform. So workwear uniform is the first segment that we do for various categories, various countries as per their needs. Then we provide biomotion, high visibility garments to our market in exports and very less in India, of course. And then we do a lot in protective fabric and garments that protects the human life from the fire hazards. So fire hazard, as we know, can be of various types and can have different situations where fire happens. It can be oil and gas industry, mining, it can be welding environment, it can be high voltage arc shoot, it can be structural firefighting, it can be wildlife firefighting. So where the when we make these garments, we need people who collaborate with us in terms of various innovative materials coming into this segment. So for that matter, we have tied up with various companies across US, UK, Europe, Japan. So where our raw material comes, the raw material is a bit of struggle for us. Otherwise, like all the human production garments and fabrics we do in-house. So if we see talking about what is good in export and what is not good in domestic is, firstly the sheer action speaks that even with the most of the population living in Asia, Southeast Asia, demand is opposite. Like we are like 70% of the population in the areas where they stay, only 30% of the produce goes. And where 30% of the world's population lives in developed countries, 70% of the human production, garments or fabrics goes there. So, talking about future of human production garments in India, if we see 2 to 3 years back, it used to look very dull and unpredictable, like what will happen, whether we should be developing anything for our domestic market or not. We should be spending some money in R&D or not, because seeing the kind of contribution coming from domestic, we were a little reluctant to do that. But recently, last 2-3 years, things have started changing with rigorous compliance and testing standards coming in India, where implementation is happening very strictly now, and I hope it will go further strict so that it increases the scope of this segment. And special thanks to Ministry of Textile, NTTM is taking, and institutions like NITRA, ADIRA, they are taking initiatives and making now companies like Arvind as their industrial partners to see that whatever development we do, it is industry always help us weighing out like whatever product we are trying to innovate, whatever material we are trying to use in the next gen protection garments or other equipment, industry always weigh out that whether it is scalable, whether it is commercial, whether it is profitable or not. Because innovation that serves the humankind is the most deserved innovation. So with that collaboration with the industry like us, the process also speeds up, like we give our quick inputs, and really thanks to the NTTM, they have come up with the step and do some funding also for the R&D. So with all these steps happening and Government of India saying we need to indigenize the special products for say segments like defense wear, high altitude clothing, NBC and other some sort of secret projects that we will be doing in India. The manufacturing as increases in India, the scope of more innovation, more production, more supply will happen. So that's my take on that. Thank you. Any questions I can?
Typical dedicated demand from government for say armed forces or protective forces, why is it not looking at I would say something as common as our urban local bodies requiring the protection for the last mile worker when he is doing very, very dangerous work in even say urban sewage disposal. Why are we trying to count only on what comes from armed forces or maybe firefighting and all that? Industry, why doesn't industry think that they can try to create a demand, because this is all covered under the ESG segment. What I am trying to say, what has deterred industry till date is an assurance of demand, domestic demand. Reason being that we have not reached out there. We have been happily giving them substandard material. Even during COVID, the people who were doing the sewage collection were given the worst material by the urban local bodies. It is unfortunately, if anybody is from that domain, I am sorry, but I think it is still, I would say, vendor driven, local contractor driven, lower substandard material driven, and one can say maybe there is some element of unsmoothness people also. But why can't we develop a demand or try to look at that demand? I am sure foundations will support. Once we make them aware that it is important for the last mile worker, We don't think that because we are too big a population, we don't think they are important for us. Yes, armed forces are important for us, firefighters are important for us. But the last mile worker in the sewage disposal, I have amazing projects being done by school kids in Bombay, and they just say, Auntie, we never saw anything in terms of a structured procurement for the last mile worker. Because there is an industry connect. I feel industry or even media is not creating a demand pull there.
Totally agree with your point, ma'am. Industry is always demand driven, and demand like if I know my army needs this kind of protective equipment, maybe in form of uniform, arms and ammunition, or special conditions, extreme cold weather or something where we need special equipment, there is a need, and there is what we are creating a solution which used to happen abroad 3-4 years back, which are now being manufactured in India. The industry is demand driven, number one. If you put compliance strictly on the last mile workers and up, we already have solution. It is just that demand has to come to us, and it is not that we are not reaching them.
I am willing to give you my good offices with whichever urban local bodies I interact. I would just to service that segment. I am willing to offer that. NMMC will be willing to do it, Navi Mumbai Municipal Corporation, Indore would be willing to do it, Surat would be willing to do it, Nagpur would be willing to do it. I can't speak for others, but I am sure once they see the value in this, because today under all kinds of compliances it is required.
Yes.
It's just that we need to see the market there and develop it. We shouldn't allow it to be through the ancillaries and through, non-standardized products which are going there.
See the difference what we compliance standards and how they implement it much more tougher over there. Even if you call to your house a gardener even, he will come in a proper uniform. How he is getting the uniform? Whosoever company, private company or contractor is hiring that guy, they provide him with a uniform first. This will give you protection, right? So if the same culture is, as you rightly said, it is not that we are totally zero on this. We are making progress, good progress on that. Gupta sir is already sitting here and he's doing a lot to make standards, and he's getting support from everywhere to implement those standards also. Once those standards and compliances are placed, obviously demand will come on, and we already have solutions for all the last 5 years. Thank you.
Thank you. Okay, now I invite our second panelist, Mr. Satin Rana, who is the Director Business Development at Diploma. He has 25 years of rich experience in the textile related industries and various chemical companies he has worked with who supplies to the textile industry. We would like him to talk about his thoughts on the growth of the technical textile industry, and especially we would like him to throw some light on the FR fabrics and the FR finishes which are available and are being marketed in India.
Thank you, Mr. Kodari, for the introduction. Also, thanks to the organizers for inviting me to this forum. When we talk about the flame retardant chemicals market globally, it is around $7 to $8 billion. In terms of metric tons, it is 2.3 million metric tons of chemicals which is consumed across the globe in all sectors, including textiles. When we talk about textiles, it contributes to 10 to 15% of it, which is roughly around $700 million, majorly into the protective clothing. In terms of tonnage, we are talking about somewhat 100,000 metric tons. And when we look at India, in terms of textile consumption, it's around $50 million of textile chemicals and around 10,000 metric tons of chemicals, which is mainly into the protective clothing. And other segments are including in protective clothing are industrial textiles, defense. Then when we talk about home textiles, it's mattresses, upholstery, curtains, and other fabrics. And when we talk about the non-textile part of it, it goes mainly into the electronics, in construction, and other little bit of uses. So in what Arcoma plays actually role into the flame retardant chemicals market. Arcoma is there from last 50 years catering to the textiles industry with a strong brand name called Pyrotex. And we also give a tag for the protection. When we talk about the global markets, how it is segregated in terms of the flame retardants. In the top, because of the fire safety regulations, majorly in Europe and US market, that contributes to around 40 to 50% of it. Then comes to the Asian market, and the major countries are China, Japan, and Korea, where due to the strong industrialization or urbanization, mainly into the construction and automotive sector, it's growing over there. Coming to India, we are majorly into the protective clothing, industrial, as well as the workwear. The most important thing is the quality standards, because we mainly work for the export market, because here the regulations are not strong. So that's why actually if you can talk about what are the different chemistries available for this finish, it's halogen based chemistries which we don't supply due to the toxic nature of the chemicals, but some people due to the cost they are still using, but it's not advisable to use the halogen based chemistries. Other chemistries which are available are the phosphorus based chemistries, which Arcoma is actually leading into the chemical front, and we have to cater industry in meeting all the global standards in terms of ecology as well as meeting the requirements as per the standards. In terms of ecology, what we say is Ocotex, Blue Sign and Boards. These are the things which we ensure with the sustainability as well as the compliance. I think that's all from my side. Thank you so much.
We'll take up some questions at the end of the presentations which we have from the panelists. I would now request Mr. Rajiv Agrawal, who is the Managing Director of the Geosense India Infrastructure Limited. They are the manufacturers of geogrids and the geotextiles and various other products. We'd like to hear from him the type of geotextiles being manufactured in India and what are the scope of geotextiles here in India. Thank you.
Good afternoon, everyone. Respected Chair of the panel, Honorable Madam Textile Commissioner, Madam Ruprashi, Honorable Professor Emeritus Shri V.K. Kothari, distinguished members of the dais, and distinguished delegates and guests. Thanks for the opportunity to share my views on geotextiles. We are manufacturers based in New Noida, manufacturing technical textiles related to infrastructure segment. We manufacture woven geogrids, geotextiles and related products for infrastructure usage. If we talk about geotextiles, we have come a long way in the last 10 years as far as the usage of geotextiles and geogrids are concerned in India infrastructure sector. Almost all the flyovers that you see across or you move on a daily basis have an element of geotextile. Rather, it is constructed with a geogrid as a main component. So I always used to say we convert yarns into flyovers. We start with the yarn and then take it up to the construction of the flyover. If we talk about geotextiles, it's a very varied segment in infrastructure sector itself, ranging from woven and non-woven geotextiles to woven or knitted geogrids. The main purposes of these is filtration, separation, drainage and reinforcement. The current market size, if we talk about geotextiles in India, official figures, they quote it around $180 million US dollars, but overall if we see the infrastructure sector alone, the figures are not less than 300 million US dollars annually. We are talking about a market size of not less than 2,500 to 3,000 crores, and it's growing. Recently, Indian Road Congress and National Highways Authority of India has allowed the usage of geotextiles for reinforcement of roads as well. That not only helps us in constructing better quality roads, but also help us in saving significant amount of money, wherein, for example, on a 6-lane highway, per kilometer of road, if reinforced with a geogrid or a geotextile, not only gives you a better road, long-lasting road, but it also saves you around 1.5 crores to 2 crores per road kilometer, depending upon the cost of the aggregate due to the reduction in the crust size, crust thickness, and reduction of bitumen. In addition to this, it serves the purpose of sustainability because it helps in reduction of carbon emission due to the reduction in consumption of bitumen. So these are some of the major advantages apart from better performing roads, better performing infrastructure, economical savings and sustainability due to the usage of geotextiles in Indian sector. The recent manufacturing of geotextiles and geogrids in India has come a long way, and we are manufacturing significant quantities and have almost replaced the imports in the country, saving a good amount of foreign exchange, right from the raw material of yarns to the finished product of geotextiles and geogrids. Thank you.
Thank you, Mr. Agarwal. I think we now request our last panelist, Mr. J.K. Gupta, who is BTech from TITS Bhiwani, 1994, so almost 30 years back. He has 24 years of rich experience at BIS in standardization, quality assurance and various other areas related to the Bureau of Indian Standards. He has presented more than 90 papers in the area of technical textiles. So we'd like to hear from him more about what are the activities of the Bureau of Indian Standards in the technical textile area and what is the quality control order in particular.
It is on dais, after dais. I think being a last panelist, it is very difficult to engage all of you. I have a very 4-5 minute presentation to all of you. All of you know the BIS, we carry out the standardization and the conformity assessment along with other activities. So I am heading the textile department, and this work through a network of 27 sectional committee under the administrative control of division council, and I am very happy to say Dr. Basu is the chair of that division council. So whatsoever the work we are doing, it is under his able guidance, sir. It all compliments to do and all your teams, sir, for that. So we have developed more than 1500, precisely more than 1572 standards in this important area. And out of this, about 600 standards are in the area of technical textiles. And from the conformity side, about 1600 licenses all over India we have granted. And there are around 118, next slide, 118 products which have been actually, the license are in operation in India and abroad, in the world also. And apart from that, this first in all India application means that whenever any industry come forward and is given the license in a financial year. So last year about 23 licenses were granted, and this year I think we have already crossed 11. So I will say there is a lot of implementation of these standards have been also there. Next slide. So these are the areas we work in, all conventional area and technical textiles also through this networks of 27 sectional committee, which involve all cotton, wool, silk, wire, physical method of test, ropes, cordages, then on technical textile, medtech, protect, we have the expert from the protect side. Our question posed to me was, actually there is a BIS Act of 2016, where there is section 16 and section 17, which actually empowers the Bureau of Indian Standard to bring a quality control order on any product or services or a part of the specification where the health of the plant, human, environment, or disruptive practices for national, there are the regions on which we can bring these QCOs. So these are the two acts, and once a QCO has been implemented, then nobody can manufacture, sell, distribute and store all those items without a standard mark. So these are the two provisions which empowered the central government through BIS to do this quality control order, and I am very happy to announce there are 91 products on which the quality control orders have been issued. Next slide. So these are the provisions, and if anybody is contravention, this is governed by the section 29 subsection 3, which actually have the penal provisions of even the jail term and the fines, or the both. Next slide. So this is a small synopsis of how we are granting. We have totally digitalized our process. There are two processes of actually granting a license. One is a simplified procedure, and second is the normal procedure. In the simplified procedure, once an application has been received, within 1 month we grant the license, and in case of a normal procedures, depending on the testing time, the timeline varies actually. So everything has been digitalized. There is a dedicated portal on which you have to upload all your documents, and then the factory surveillance and the market surveillance and the testing of the sample is being conducted. Next slide. So I was discussing there are 12 products on protective textile, 19 on geotech, 20 on agrotech, 3 on medical textile, another 6 on medical textile. Recently on this ropes and cordages also, 9 standard have been brought under the QCO, and on geotech 1 polymer carrier is also brought under QCO. Indutech is on this webbing slings. So in all, next slide. So in all we have there are 91 products actually. Most of these have been implemented. I should compliment the Ministry of Textile especially to bring this QCOs, and there has been a very smooth transition in most of these cases. Only we are actually struggling for this medical textile items, especially in the area of sanitary napkins and the baby diapers, and which may take some time because they are the mass consumption items. And if you see the effect of this QCOs, I want to give a very small simple example of the mother yarn. There is a standard FDY, the fully drawn yarn governed by IS 17261, and I receive more than 400-500 emails from different stakeholders through ministries and PMO also to examine that item of this mother yarn, because there is some issues and all. but I am very happy to announce there has been an import of more than 4,000 crore of this item, which has been totally stopped because of this QCO from the countries which are basically the adverse countries, and we do not promote the import from those countries. So it is a very good case study for me also, and I am very happy to announce that segment has increased their production capacity in a period of 6 to 8 months by 40%. The market was about 8 to 9,000 crore and they have gone 14,000 crore plus. So now the impact of this QCO is very good, provided we actually wholeheartedly as a stakeholder, we support those initiatives of Government of India for the benefit of all. It is a win-win situation for everyone. So these are all I have to say. Thank you very much for that. Thank you.
Thank you, Mr. Gupta. Now I will request the Textile Commissioner, Ms. Lukrani ji, to say a few words.
Shri Satin Raina ji, Mr. Rajiv Agrawal, Mr. J.K. Gupta, and all the esteemed participants. I'm very thankful that I've been made to chair this session. Personally, I feel grateful because any interaction with all of you has made me learn new things, and in my capacity as a field officer for the Ministry of Textiles, I've been able to maybe spread it at different levels, whether vertically or horizontally, in terms of various related ministries or various level of governance. And I feel very, very enthused about any such interactions which I have been where we could have maybe some MOUs which could be intra-TRAs or inter-institutional MOUs which could be made part of this. We could have with some industries. Industries could announce some of the projects they are taking with us, which could be part of our such conferences also, because that enthuses the new generation in terms of the prospects which are not theoretically just explained. They see it happening across industry, and we could have some more exchange programs for our amazing students as well as researchers. Please just ponder over it. With these few words, I once again thank everybody, and especially thankful to Ministry, NTTM, and all our participants here who have contributed to this knowledge exercise, because without constantly evolving on our knowledge platform, I am sure industries don't grow, even if we are one of the oldest in textile domain. Thank you everybody.
Technical textiles in general, and in some cases a particular type of protective textiles, geotextiles, standards, and the chemicals being used for the technical textiles as well as textiles in general. We would have loved to have a few questions from the audience, but due to the lack of time, probably we will skip that, and we would like to thank all the speakers and all of you for very patiently listening. Thank you very much.
Thank you, Rukrashi ma'am and Professor Kothari, for conducting the panel discussion so well, and my thanks to all the panelists for expressing their views. Now I will request Rukrashi ma'am and Professor Kothari to jointly felicitate the panelists with 60-second JTC memento. Please. I would also like to invite Mr. Ashok Malhotra ji, Mission Director NTTM, sir, to please come on the dais and join us. Sir, please. Thank you. Mr. Satin Raina. Finally, Mr. J.K. Gupta, sir. Thank you, ladies and gentlemen. I would like all of you to please take your seats back. To felicitate Ruparashi Madam with 62nd JTC memento. Please come, sir. Thank you very much, sir. Now, sir, to please join and felicitate Ashok Malhotra. Shri Ashok Malhotra ji, Mission Director Entity. Thank you, sirs. Please, ladies and gentlemen, Dr. M.S. Parmar, Director NITRA, is the coordinator of this 62nd JTC. He has been instrumental throughout in organizing this event and kept guiding and coordinating with his team in NITRA as well as with other people who are associated with this JTC to make this event a success. Now I request Dr. M.S. Parmar, Director NITRA, sir, and Coordinator 62nd JTC for delivering the formal vote of thanks and conclude the conference, sir.
Thank you very much. I will not take much time. Respected NITRA Chairman, Shri Vidit Jain, at this moment he is not here, but yesterday he was here. Textile Commissioner Madam, Ruparashi, and Director Adira, Mitra, I think they have left because they have to go to airport, and SITA Director is here, and also our Mission Director Malhotra sir, and all the panelists over here, ladies and gentlemen, of course my Director General, and ladies and gentlemen, it is customary for Coordinator JTC to officially conclude the conference with a note of thanks. Personally, I feel extremely happy to coordinate this wonderful event, and now it is my duty to acknowledge the contribution of all those who are behind the success of this great show. To begin with, I express my sincere thanks to our chief guest, Sri Giriraj Singh Ji, Honorable Union Minister of Textiles, for his presence on yesterday in the inaugural session to grace this occasion. I thank the chairman and deputy chairman of NITRA for their encouraging presence. I also thank senior MOT officials, Madam Ruparashi ji and Sri Rajiv Saxena ji for joining us in spite of their busy schedule. We also thank defense officials who have come over here and graced the occasion. We are thankful to Ministry of Textiles for supporting this event. I thank the head of Adira, Mitra and SITA for supporting us, for continuing the legacy of holding the JTC, because you know that this is a 62nd JTC, means 62 years have been passed now, and we hope that it will continue in future also. I also thank our Director General for all his support. I am grateful to all session chairmen for spending their time witnessing and evaluating the presentations. At the same time, I express my sincere gratitude to all the distinguished panelists from the industries and especially Professor Kothari for moderating the panel. Thank you very much, sir, for here. And in the middle of that, I just want to mention one more line that all the papers are now available on our websites. papers are, we have given a link, you can download all the papers which have been presented over here. I also would like to thank Madam that has awarded over 24 years, you can say our pillar of NITRA. They have worked over here 25 years and they have built this NITRA. And thank you very much, Madam, for this gesture. Frankly, I also put on record my sincere thanks to the authors and presenters of different technical papers. I strongly believe that they are the actual lifeline of a techno-commercial or techno-conference like JTC, that is Joint Technological Conference. I convey my thanks to all the delegates for being with us and making the 62nd JTC a success. The young and energetic poster presenter also deserve a big thanks for adding color to the conference. It is my duty to also thank our sponsors and exhibitors for their active support to organize such a wonderful show. I would like to thank you, management of Arvind Limited, RSWM, Mahavir Spinfab, Kusumgar, Geosys India and Super Limited, and silver sponsors Raymond, Bronze, Kanpur, Plastic Bag, and so many of them have sponsored this conference. And this is a surprising thing that we could able to ask them to sponsor, and they ready immediately. That is a good thing that NITRA is progressing, ma'am. Thank you very much. Our exhibitor Shiva Industries, Asian Test Equipment, Star Safety Hub, and Jaivic Care, Hemp Affairs, Department of Handloom and Textile, Mahavir Spinfab, Chlorohem, and Satnam Enterprises. They are also our exhibitors, and we are thankful to them also. Our media partner, Colorage, Textile Value Chain, Fiber to Fashion, IGF, they have published our conference, and that's why people could understand that this is going on over here. I also thank the advertisers in JTC books, because many of them have given some advertisement in their book of abstracts. We are thankful to them also. And last but not least, I extend my thanks to my colleague from NITRA for putting this tremendous effort day and night, because we know that in the last night at 3 a.m. we were all doing some work over here. So this was a very hectic activities, and day and night they have engaged with us, me and all our that core team are always busy for making this event successful. We want a big clap for them. With this, I conclude the 62nd Joint Technological Conference. Thank you all. Thank you very much.
Thank you, Dr. Barman. So, ladies and gentlemen, with this we conclude the 62nd Joint Technical Conference. Now, on behalf of Dr. Arindam Basu, Director General Sir, who has been the guiding and motivating force behind this event, I invite you all to join us for evening tea. So, have the tea, have a nice day. Thank you very much.
Was jointly established by Textile Industry and Ministry of Textiles, Government of India. NITRA is partly funded by Ministry of Textiles, Government of India. This organization is registered under the Societies Registration Act 1860 and recognized by DSIA, BEE and PCI. NITRA facilities are recognized by leading textile institutions and universities for their postgraduate and PhD program. It is an ISO 9001-2015 certified research organization. NITRA's all labs are also accredited by NABL against ISO IEC 17025-2017 and inspection activities being accredited by NABCB against ISO IEC 17020-2012. NITRA is serving the nation since 48 years and is recognized as a center of excellence for protective textiles by Ministry of Textiles, Government of India.
Under the India Textile Research Association, shortly known as NITRA, has been set up by Ministry of Textiles. 10 years ago, we have been accredited as Center of Excellence for Protective Textiles. It has developed a number of products which has been commercialized and widely used by the paramilitary forces and army.
Recognized as Center of Excellence for Automotive Textiles, Mobiltech by Office of the Textile Commissioner, Mumbai. NITRA, since its establishment, has developed a lot of products, and some of the important and major products are improved version of body protector for rides control, multi-layered flame and thermal resistance fabric for firefighter clothing, fabric and garments from pine needle fiber, biodegradable fiber yarn, fabric and garments, chef dress for Indian Navy. Protective work wear for cement coated, fabric for stab-resistant belts, coat combat disrupted, regenerated cellulosic fiber from Indian bamboo using NMMO process. Smart textiles for old age people and security personnel for their health monitoring in case of emergency. Apart from these products, NITRA has the credit of developing lot of instruments. Also, some of the major instruments are synthetic blood penetration tester, breathability tester for masks, bacterial filtration efficiency tester for masks, apparatus to determine air pollutant gaps absorption capability of fabric, stab and impact resistance tester, smoothness tester for textile sheeting materials, electronic date reader based on image analysis technique. NITRA has not only developed the products and instruments, it has commercialized its developments through technology transfer as technology to process raw banana fiber is transferred to Gentrust Bioproducts Private Limited The technology of splash-resistant wood for Indian Navy is transferred to Messrs. Aero Garment. The technology of improved version of body protector for rights control is transferred to Messrs. GM Trading and Messrs. Flight Systems. Good Combat Disruptive Technologies is transferred to Usumgar Corporate Private Limited and Radnick Exports. The technology of reusable sanitary pads and diapers is transferred to Patent Industries. Technology of synthetic blood penetration test to Asian Test Equipments Ghaziabad. Technology of work wear for cement porter to Messrs. Arvind Limited, Ahmedabad. Technology of developing multi-layered flame and thermal resistance fabric for firefighter clothing to Arvind Limited and Aeronov Industrial Safety Appliances. Technology of Nitra electronic grade meter to Deal Technologies, Coimbatore. Technology of Nitra's fabric smoothness tester to Multi-Flow Instruments Private Limited, Navi Mumbai. Nitra has its own testing infrastructure and other textile machinery situated in the campus. If we talk about laboratory infrastructure, it consists of Physical Quality Evaluation Lab, Chemical Quality Evaluation Lab, Heat and Flame Test Lab, Polymer and Technical Textiles Lab, Microbiology Lab, Eco Lab, and Environmental Lab. Nitra's pilot plants and workshops are Spinning Pilot Plant, Weaving Pilot Plant, Natural Long Fiber Pilot Plant, Knitting Pilot Plant, Chemical Processing, Swing Machine Workshop, Garment Dyeing and Finishing. Nitra has established his name and set up prominent labs of yarn, fabric, garment manufacturing laboratory. It has also an embroidery lab, 6 testing labs and CAD labs. So we come to know that the core activities of Nitra is research and development, training and education, consultancy services and testing services. Nitra organized various conferences and conclaves. One of the recently organized conclave was on National Conclave on Technical Textiles, ProTech. This was inaugurated by Secretary Textiles. Nitra is proud that they have 1,200 clients in India and its clientele is spreading beyond India in countries like Ethiopia, Indonesia, Sudan, Bangladesh and Nepal. Northern India Textile Research Association has been awarded as the top 3 innovative research institute under Innovation Quotient category amongst all research institutes in India by CII Industrial Innovation Awards 2022. Today, Nitra services are availed by textile and garment factories, international testing labs, central and state government organizations, trade bodies, academic institutions, and non-textile sectors. Broad areas of research and development of Nitra are product development, process development, technology development, instrument development, need-based research. Nitra, an organization of India, is the talk of the textiles industry in the world, and that is due to their long-term experience and sheer honest commitment of the talented techno-persons who are making the country proud. Nitra, the ultimate destination for the textile industry.
जॉइंट टेक्नोलॉजिकल कॉन्फ्रेंस अभी हम 10-15 में शुरू करेंगे, तो मैं अनुरोध करता हूँ सारे डेलीगेट्स प्लीज अपने अपने आसन ग्रहण करें। थैंक यू वेरी मच।
Leading textile institutions and $40 billion and export of $10 billion by 2024 to 2025. Minister of Textiles, Commerce and Industry and Consumer Affairs, Food and Public Distribution, Shri Piyush Goyal's direction and vision of Prime Minister Shri Narendra Modi, Textile Ministry promote usage of technical textiles in various flagship missions, programs, including strategic sectors in India, improve penetration level of technical textiles and upgrade skill set of the workforce, develop indigenous machineries and process equipment for technical textiles to promote Make in India and enable competitiveness of the industry, promotion of innovation amongst young engineering, technology, science standards and graduate, along with the creation of innovation and incubation centers and promotion of startup and ventures. Technical textiles has 12 segments: Meditech, Mobilitech, Ukutech, Bagtech, Growtech, Sporttech, Agrotech, Buildtech, Clothtech, Geotech, Hometech, and Indotech. It's now time to talk about protective textiles. What are protective textiles? Protective textiles are one kind of technical textile that is used to protect humans and properties from various types of hazards. These textiles provide protection against hazards such as heat, fire, blast, impact, currents, chemical splashes, dirt, nuclear, biological, chemical, mechanical, electrical, cold, rain, snow, wind, UV radiation, and many more. These types of textiles are used by workers working in hazardous industries like steel, aluminium, copper, oil and gas, cement, military, and paramilitary forces. Besides, protective textile has a very important role in the protection of humans and properties in public places like cinema halls, railways, hotels, hospitals, and many more. Let us have detailed information on these protective textiles. Starting with firefighter suit. These are used by firefighter in case of fire to save human life and property. Bulletproof jackets. A bulletproof jacket or vest. A bulletproof jacket is an item of body armor that helps absorb the impact and reduce or stop penetration from firearm fire projectiles and fragmentation from explosions. Full body protector. A full body protector is a personal protective ensemble used by law-protecting bodies for physical protection against brick batting, cane, knife, acid attacks, and projectiles encountered in a riot situation and other violent encounters. NBC suit, nuclear, biological, and chemical suit. Its components and functions. The NCB suit can provide continuous protection to the personnel with chemical agents in liquid, aerosol, and vapor. Nuclear and biological threat. It has water and oil repellent and flame retardant properties as well. Extreme cold weather clothing. Extreme cold weather clothing refers to clothing for Arctic or mountainous areas. Its primary function is to trap air as an insulator to prevent heat loss from the wearer's body. It also helps in keeping the water vapor away from the body to keep the insulating layers dry. One such type of extreme cold weather clothing system, ECWCS. ECWCS is a 3-layer system comprising 6 components. These are inner layer of jacket and trousers, middle layer of jacket and trousers, and outer layer.
Good day, ladies and gentlemen. I am Dr. Sundamurthy. I am thrilled to welcome you all. I trust you are eager and ready for the technical session we have lined up. So without further ado, let's get started and set the things in motion. It is my honor to invite Professor Abhijit Majumdar from IIT Delhi to chair the composite and sports textile session of the conference. May I kindly request Professor to take his seat on the dais. Abhijit Majumdar is a distinguished figure in the textile community, both in India and internationally. Although he hardly needs an introduction, it is customary for me to take this moment to formally introduce him to all of you. So, Dr. Professor Abhijit Majumdar is currently serving as the R. Jayakumar Chair Professor for Decision Sciences in the Department of Textile and Fiber Engineering at the University of Technology, Delhi. He brings over 25 years of academic experience, complemented by 2 years in the industry. His research spans across soft body armor, 3D weaving, and advanced textile composites. Dr. Majumdar has authored 2 textbooks and edited 5 more while publishing 175 peer-reviewed research papers. His contribution has earned his numerous accolades, including the prestigious Eminent Engineering Award from the Institute of Engineers, India, as well as IIT Delhi's Best Industrial Relevant PhD and Master Project Supervision Awards in 2023 and 2019. Dr. Majumdar has also received the Gandhian Young Technological Innovation Award 2016 and 2021 and Teaching Excellency Award in 2015 and Outstanding Young Faculty Fellowship from 2009 to 2014. So may now request Mr. Kushwathra Prakash, Principal Scientific Officer from NITRA, to honor our chairperson with a bouquet. Dr. Partha Baini, Research Associate Atiha, Mr. Dinesh Mariwale, Senior Research Fellow WRA, and Dr. P.V. Srikumar Sir, Director Mitra, Dr. Ankush Sharma, Scientific Officer Atiha. Majumdar to kindly begin the proceedings.
Good morning, everyone. So I welcome you to the first session of day 2 of 62nd Joint Technical Conference. So in this particular session on sports textiles and composites, we have 5 technical papers, and I have been instructed that the session should be over by 11:30. So we have 40 minutes of time. We have 70 minutes of time, So maybe I request all the presenters to limit their presentation to 12 minutes so that we get some time for the question and answer. So the kickoff speaker for this session is Dr. Rupam Chauhan. Okay. She is Senior Scientific Officer of NITRA, and topic of her presentation is Impact Protection and Comfort Characteristics of STF-infused 3D knitted spacer fabrics. So I will introduce the speaker also. Dr. Chauhan is a Senior Scientific Officer of NITRA. She completed her BTech from Jawaharlal Nehru Government Engineering College, Sundarnagar, and MTech and PhD from NIT Jalandhar. She has published 5 research papers and 6 conference papers. She has authored 1 book in the NITRA notice series and also contributed as an author to the book chapters on knitting technology. So now it is over to Rupam Chauhan. Thank you.
Am I audible? Very good morning to one and all present here. I am Dr. Rupam Chauhan, Senior Scientific Officer of NITRA, and I am going to present a project which we have done here, that is Impact Protection and Comfort Characteristics of STF-infused 3D knitted fabric for sports textile. Dr. Anindam Basu, our Director General, was the principal investigator of this project. So first, introduction. First of all, we need to know what is protective clothing. Protective clothing basically refers to any garment or any fabric that is specially designed to protect the wearer from the harsh environmental effects which may cause any harm to the wearer. It may be any injury, it may be even death. And there are different categories of protective clothing, and sports protective clothing is one of the categories, which is exclusively designed to protect sports persons from the injuries that can occur during any sports activity. Commercially, there are actually so many varieties. Like these are some of the examples. We have knee pad, shoulder pad, bracer, helmet, leggings, goggles, leg guards, etc. And maximum of these they are using commercially closed cell commercial foam. The data of these commercial foam is given in this slide, and from this slide it is clear that the fabric or the foam is actually very thick. It is 15.3 mm in thickness and its GSM is 582. In fact, load and compressional resilience is quite good in terms of the protective properties, but if we see the comfort properties like air permeability, thermal resistance and water vapor resistance, then it doesn't provide that much comfort. Especially air permeability, it is giving us zero air permeability, which means there is no air that is passing through that foam. Then what are the problems with this product that is commercially available? So as I have already discussed, that the main problem is the thermal comfort, then other are durability, shrinkage after laundering, dimensionally unstable, then inappropriate fit. So we need someone that could be replaced in case of this commercial foam. So spacer fabric is now of keen interest to different researchers, and this spacer fabric, it is a 3D structure that consists of two layers, top layer and bottom layer, which are connected together using spacer yarns. So these are the two of the figures which clearly shows how the spacer yarn in between is connecting two layers, top layer and bottom layer, and this is the spacer yarn that is in between, which is actually providing us the protection. So there are two reasons why we have chosen this spacer fabric. First is the properties that give it impact protection. First is the resilience that is provided by the conducting filaments that is present in the between, and second is the energy dissipation that is also due to the connecting filaments. And the second one is comfort properties, because it is quite compressible, it has a good air permeability and water and air good heat transmission. So that's why we chose this spacer fabric. This figure clearly shows how it is doing that. So the airflow in between, as there is a lot of open space present in this fabric, so that provided good air permeability, and also the transmission of heat and liquid is also enough to the top and bottom layer. Then after that, as the topic is STF infused 3D spacer fabric, so we need to understand what is the shear thickening fluid, that is STF. So for that we need to understand Newtonian and non-Newtonian fluids. So first is Newtonian fluid. These are those fluids which we usually see in our daily life, that they have a constant viscosity which doesn't change after when we change the shear stress. For example, water. And the second one is the non-Newtonian fluid, which is the one whose viscosity changes. Like if we apply a certain force on that, then sometimes it is higher viscosity and sometimes it gives lower viscosity. For example, we have paint. This graph simply shows the same case. Here the center line, it shows the Newtonian fluid, which shows the linear relationship between stress and shear rate, and the bottom line, it shows the shear thickening fluid, where the shear stress goes on increasing with shear rate, and the top one shows the shear thinning fluid, where shear stress reduces when we increase the shear rate. Then coming to shear thickening fluid, that is STF. It is one of a non-Newtonian fluid which shows an abrupt and discontinuous increase in viscosity beyond a critical shear rate. This is one diagram which clearly shows the behavior how a shear thickening fluid behaves. So first is when it is in equilibrium state, at this point its viscosity is constant, and after that comes the shear thinning stage where the viscosity reduces with increase in shear rate, and after that there comes a critical point which is called as a critical shear rate. At that point the viscosity suddenly strikes to a higher amount, and that time the fluid is converted to shear thickening fluid. This is one simple example that we can see. Here the beaker contains a non-Newtonian fluid, and the first case is where a ball is dropped from a lower height and it simply sinks into the fluid. And second one is the case where the ball is dropped from a higher height. So if it is dropped from a higher height, then the force applied will be more. So in that case the fluid will convert to solid state. That is, it will convert into a shear thickening fluid, and ball will simply bounce back and it will not sink into the fluid. So this is simple example how this shear thickening fluid acts. Then objectives of this project were development of 3D spacer knitted fabric, preparation of shear thickening fluid, then impregnating 3D spacer fabric with prepared STF, and last one, evaluation of comfort and impact protective properties. So this is how we have developed 3D spacer fabric. We have here in Nitra our Shima Shaky packed bag knitting machine with case 16. We have developed all the fabrics in this machine. Fabrics which we have developed. We have developed 4 different fabrics by varying the thickness in the outer yarn and the diameter in the middle yarn. We have used nylon multi-filament in the outer portion and nylon monofilament in the middle portion. That is our spacer yarn. So preparation of shear thickening fluid. We have used fumed silica from sigma average of having particle size 0.2 to 0.3 micrometer. So this is the basic process flowchart how we have produced that. So first of all, fumed silica was dried in hot air oven at 100 degrees Celsius for 2 hours, and then this fumed silica was added to PEG at room temperature 1 gram at a time. Actually, generally if we add much more together, then it will form clusters. So we add this gradually. Then after that, it was mixed in magnetic stirrer at 1200 RPM till it becomes transparent. After that, we sonicate the mixture in ultrasonic probe sonicator for 12 mm probe for 30 minutes, and then this process was repeated until whole of the fumed silica was utilized. This is how it was manufactured. The first one is where initial stirring was done in magnetic stirrer. Second one is the case where it was sonicated, and third is where we get the clear final STF. So this is the rheologic property of prepared STF. We need
2 minutes remaining.
So this is the result of the rheologic property, which actually shows whether the fluid is giving shear thickening results or not. So out of 5, we got the results in 4 different concentrations. Sorry, 2 different concentrations, 40 and 35%. So then STF was applied on 3D spacer fabric simply by dip coating. And then evaluation of comfort and impact protection, different impact protective properties and thermophysiological properties was evaluated as per the standard test methods. So these are the results. First is the thickness. We can see that there is a slight increase in thickness. It is simply because the fabric that is STF coated, it does not compress easily. Then impact protective properties. First is our bursting strength and puncture resistance. In both the graphs we can see that the fabric that is coated with STF is giving better results, better bursting strength as well as better puncture resistance. And the third one is the ball impact test, where we have checked the impact of ball when it was dropped from a certain height doing STF coating, it is simply because STF has a tendency to form clusters when a higher amount of force is applied over it. So this is simply due to that. Then thermophysiological comfort properties. Here we have not shown the data of fabric with STF because there was we are still under process in this project. So I have just simply given how it is better than the commercial foam. So we can see that thermal resistance of commercial foam is very high as compared to our all the four spacer fabric. And second one, same with the water vapor resistance. And third is air permeability. Commercial foam is having zero air permeability, and all the spacer fabric they are showing very good air permeability. So in all the terms, our spacer fabric it acts as a better option for the in case of a commercial foam. So these are some of the conclusions that application of STF improves our impact protection properties, and the average percentage increase in bursting strength and puncture resistance after coating the fabric was 6.24 and 9.2% respectively, and depth of ball impact also reduces. Then air permeability, thermal resistance and water vapor resistance, they also show better results. So it is finally concluded that STF can be incorporated into 3D spacer knitted fabric to prepare impact resistant equipment that can be used in sports textiles. So these are some of references. So thank you so much.
Correctly. Okay, he's a very young and prolific scientist, I must say. So Dr. Partha is a senior scientific officer at Ahmedabad Textile Industries Research Association, that is ATIDA. Before joining ATIDA, he worked for nearly 7 years in Japan and Singapore. He holds MSc in chemistry from IIT Madras and PhD in polymer science from Indian Association for the Cultivation of Science, Jadavpur University. And Dr. Bairi has published 57 research articles in peer-reviewed journals with a very impressive H index of 30. So now he will be presenting a paper entitled Graphene Coated Natural Fiber Reinforced Composites with Improved Mechanical Properties. Over to Dr. Bairi.
For the kind introduction. And today I am going to introduce what ATIDA actually doing in the development of a nanomaterial integrated FRP-based composite for advanced application. Okay, this is my outline of the talk. As you can see, first I will show some of our recent research which we have done at ATIDA. Yeah. I think all of you know that I think Indian composite industry growing very fast, and you can see the predicted market value in 2027 is around 2 billion, and the growth rate is quite impressive. And another thing is that most of the composite products are demanded mainly in aerospace industry, defense, construction, energy, mass transport, as well as road industry. However, if you compare per capita consumption in India is quite low compared to the advanced economies like USA and Germany. And another thing is, Indian composite industry share only 2% of global composite. So this data actually gives you some idea. There is a lot of opportunity to grow in this area. Yeah, I think many of you already know what is the composite materials. And these composite materials, humankind used it for a long time ago. Even Mother Nature also used these composite materials. As you know that our body itself is a composite, and in order to make FRP-based composite, you need two components. One is a reinforcement fiber, which is basically we used natural fiber-based as well as man-made fiber like carbon fiber as well as glass fiber. And we also need matrix. Generally we use polymer matrix, which is basically thermoset as well as thermoplastic. Now the question is why industry very interested to this advanced material. Two major reasons. One is lightweight of this advanced material and the strength. And actually there are many methods available in order to produce this advanced materials based product. However, in Atira we are mainly doing hand-layup, accommodation, pultrusion, compression molding as well as refracting. Most of the composite based product mainly used more than 50% in aerospace, defense as well as energy sector. However, you can also see that there are many sectors where you already used lots of composite products. Now I will show you two important projects that we are pursuing right now in composite. First project is we have developing a slotted waveguide antenna, and this project is sponsored by JTC recently. And the end product of this user is ISRO. Right now they are using slotted waveguide antenna using aluminum alloy based materials. However, aluminum alloy has a very high density. Therefore, to reduce the weight, they wanted to replace aluminum with carbon fiber based composite. And the problem of this carbon fiber composite is the surface conductivity. You can see the surface conductivity of FRP based composite is very poor. However, in order to make slotted waveguide antenna, you need a surface conductivity around 10⁵ Siemens per meter in this range. Therefore, we formulate graphene based ink, high conductive ink. You can apply this ink to the composite surface and you can reach the surface conductivity around 10⁴ Siemens per meter. And after that you can easily apply electroplating and you can get the desired conductivity. One more project we are right now pursuing, that is development of flexible FRP based composite for deployable phase antenna. I think many of you know that the traditional FRP based composite is very hard and brittle because of the matrix that we use is epoxy resin that is very hard and its elongation only 2 to 3%. However, in order to make the highly flexible FRP composite, you need a flexible matrix. Now, this kind of epoxy resin, highly flexible resin, is not available in the Indian market, and that's why we have formulated two different, epoxy resin, and you can see that it can fold 180 degrees easily. And now I will discuss why natural fiber. Why natural fiber is very important in composite industry. If you compare natural fiber with man-made fiber like glass fiber and carbon fiber, you can see that carbon fiber strength is highest. It cannot be replaced with natural fiber based composite. Now if you see the glass fiber, almost all these properties are intermediate if you compare the natural fiber and carbon fiber. And if you compare the glass fiber with natural fiber beats over glass fiber in terms of cost. free cycle level as well as energy consumption and specific of weight. Now the one main problem is the tensile strength of glass fiber based composite. If you make a high strength natural fiber composite, if you include the properties of natural fiber based composite, especially mechanical property, you can basically replace the glass fiber based product with natural fiber based composite. This is one of the specific examples where jute based composite and glass fiber based composite is used in carbonate application, and in that case you can see social, economical and environment, all these aspects are favorable for jute based composite. The only problem is technical. So therefore at Apira we are trying to improve the technical properties, mainly mechanical properties as well as the reproducibility of the strength of natural fiber based composite. So by doing this you can replace glass fiber based composite, especially in some of the specific application. Therefore we are interested in various nanomaterials, especially graphene and carbon nanotube, because of its high strength and low density. Apart from that, these nanomaterials possess very high thermal conductivity as well as electrical conductivity. So at the end result, you can also get this kind of properties to the traditional FRP-based composite. If you introduce nanomaterial to the FRP-based composite, you basically introduce new functionality, and by doing this you can use these functional materials in various applications which I have listed here. And this kind of application cannot be done using traditional FRP-based composite. And if you compare the traditional versus nanomaterials modified FRP composite, you can see if you use nanomaterial, weight reduction is possible. At the same time, you can improve the mechanical property, you can introduce electrical conductivity, improve thermal conductivity as well as TG. And after that, you can improve the performance, and you can also use it in novel application which I have already present in the earlier slide. But the question is how about the cost? Right now in India, cost of nanomaterials is relatively high. However, there are many industries, they are now starting, selling good quality nanomaterials in the market. So I believe in the next 5 to 10 years, this cost will be dropped. However, if industry used little extra cost right now, they can get several advantage which is worth, especially improve performance. And another thing is you can solve the new, very old problem which is not possible to solve it using FRP-based composite. And another thing is in terms of sustainability, this is also good. Another question is how one can introduce nanomaterial in the FRP-based composite. There are two methods you can modify. Modification of reinforcement, and another thing modification of matrix. And by doing this, if you use the modified reinforced and modified resin, you can basically end up with nanomaterials modified composite. In Akira, we are doing both the methodology, but today I will show you only one methodology. To prove this concept, we just took jute as a model natural fiber because of its availability as well as intermediate mechanical strength. And first we did alkali treatment. As you know that alkali treatment can improve the crystallinity because it removes some of the amorphous part
The third presentation, thank you so much. The third presentation of this session will be given by Mr. Dinesh Marewar, Senior Research Fellow from Wool Research Association. Mr. Dinesh Marewar has earned the MTech in Fiber and Textile Processing from ICT Mumbai, and he has published many peer-reviewed articles in leading journals. His current research explores innovative strategies for integrating the recycling of textile waste and agricultural waste to mitigate environmental degradation. So over to Dr. Dinesh. His topic of presentation is again something related to protection, design and development of lightweight cricket pads using non-Newtonian fluids.
Protective equipment like helmets, arm casts, leg guard, cricket pads, etc. Then mostly in the cricket pads we are using the PU, UVA and high density PE foams for the inner material as the inner material for the development of the cricket pads. Here in traditionally if we see the cricket pad evolution in the 1870s, during 1870s, we are in that time we are using mostly cane-based or leather-based cricket pads. After in the early of the 90s, we are using the wood canes plus some pillow as a supporting material as a pillow covers. Then after we go in the mid-90s we focus towards the foam materials, with different foam materials, and in the year of 2000 we are using PU based foams. Currently, if you see in the first presentation also, that is STF is the future for the sports composites, and here we have used the STF base we have prepared STF base PU composites for the development of the cricket pads. The future will be depend on the it's mostly on the 3D printing of the mold cricket pads. Non-Newtonian tools are the material which viscosity changes when under applied the sprays. There are the two types of the non-Newtonian fluids, like that is shear thinning fluids and the shear thickening fluids. Here we use the shear thickening fluids for the cricket pads. This is the preparation method we have developed. We have conducted in our laboratory at WRA. This is the preparation method. We have optimized the parameters also for the we have concentration of nano-silica that is for the 10 to 30% of weight, and by using mechanical stirrer with 800 RPM around 10 minutes. After that we have solidified the samples to remove the air trapping. These are the piezo parameters of developed STF. We got density around 60 to 80 gram per liter. The surface area is around 200 in the range of 200 to 250, and its particle size is around 12 to 15 nanometers. We have prepared PU composites and STF fluid is as a filler for the development of the composites. First we have STF with mass of fabrication with 30% of mixed with the polyester glycol by mechanical stirring. Then we have added the isocyanate for the for the reaction between the isocyanate and polyester with the ratio of 1:3. And then finally mixture was quickly poured into the mold, and finally the seal for the 3 weeks at room temperature. This is the graphical outline of our process, and we are characterized by these
From the FT and we will see the STF and PU composite shows there is no chemical. This is the only physical interaction of STF with the PU composite. There is no chemical bonding between the STF and PU. As shown in the we can conclude it from the FTR graphs, and from SEM we see the first image A, that is A is the for the that is PU based, and second one is the STF pillar PU, that is the aggregated molecules shown in the as a SEM image. This is our prototype development. We have developed cricket pads using some our conventional method like pattern making, cutting, then pattern drying, first stitching, then material cutting, then material filling, and the final stitching. These are the results we got, and we compare with the 3 commercial samples and our developed samples. More or less, in case of density, we got lesser density than the commercials one. These are the tensile strength is also comparable to the commercial ones. Tear strength also we have checked the tear strength. These are also comparable results of our developed samples. Main motive is our project is to develop a lightweight cricket pad. This we developed samples, we got 11.25% decrease in the weight of the developed cricket pads when we are comparing with the commercial samples. We have checked the gait analysis of our developed cricket pad by walking and running at the JVR Mumbai. These are with the commercial took place from the domestic club of Mumbai. And we also compare the joint angle comparison. Here we are analyzing the movement of the joint, that is knee. We have incorporated and designed the knee pad for the cricket pad. From this we go for the comfortness of the cricket pads by running and walking. This joint comparison shows that our developed knee pads which is incorporated in the cricket pad, which is beneficial for the cricket players by walking and running. These are the graphs, that is where upper image shows commercial pads, and below is our developer pads. This blue line is the reference line. We can see our developed pads shows the comparable with the reference lines only, which conclude that is when player is when walking and running, that's knee movements are the in the comfortable zone only. We have checked with running and walking with 2 players, like with the commercial pads, which for the walking, its time shows 4.20, and with our developed pads, it shows like 2.89. And when we are running we have checked with the running also. Commercial pad shows 14.54 seconds, and in our cricket pads it's like a 10.98. For plate was the same, that is a 5.61, and without developed pads that is 3.32. While with the running it shows 15.53, and with our developed pad that is 11.16. These are the impact resistance tests we have conducted by the VAPM KWI method, that is stab and impact resistance. We observe the no deformation of the cricket pads, developed cricket pad observed as the commercial pads. Same with the full top method. We have